give them food too?
Yes, yes. Actually, they are
See?
food.
See? No, you're never gonna come.
Carbohydrate.
Salty.
What? Carbohydrate. Okay, the function.
Should I write or will you write and I listen?
No, I write everything. The function of carbohydrate, okay, that's important because it's coming to the exam. Direct energy source in the polymer form, that's the energy storage. Starch is just in the plant, glycogen is just in the animal. Skeletal carbohydrate, for example, in the cell wall in the plants like cellulose, or in bacteria, and component of skeletal protein. Building, this is number 4, building block of biologically active compound, the GAG, glucose aminoglycan. You know it from the biology.
Yeah.
In antibiotic, alkaloid, nucleic acid, ribose, deoxyribose. On the cell surface for the signal transmission receptor like a GLUT. GLUT 1, GLUT 2, GLUT 3, and GLUT 4. Okay. They are the important one. Marker? Because you like the marker.
What is she doing? She's like all the time.
Me? Me?
Very good.
Oh, bismillah.
Oh my god.
The structure of carbohydrate. Polyhydroxyaldehyde or polyhydroxyketone. Aldose and ketose. You know it, yes?
Yeah.
Okay, again, you know this one. The general formula is CH2ON times or CnH2OM times, and N and M should be more than 3. Fucking. No, classification. Monosaccharide, oligosaccharide, polysaccharide. I'm sure you know them. We don't go through that. Classification is important. Glycoconjugation, glycoprotein, glycolipid, and protoglycan, all of them are important. With this.
Just reading, yeah?
Yeah, just read it. No, the structure is starts from the here. First of all, I want to ask you, what is the name of tricarbon? CCC.
Metan, etan, propan.
This is the propan. Aisha?
Yeah.
Aisha,
Metan,
come here.
etan, propan.
Come here.
Yeah, I'm here.
If I put here 1 OH, the name will be
Propanol.
No. If I put 2 OH, the name will be propandiol. And this 3 OH, the name will be 1 and 2 and 3 propan. Triol. Always on the exam they ask, what is the IUPAC name of the glycerol? That's
1,
it.
2, 3.
IUPAC name of glycerol. Important. Good?
Perfect.
Now, this OH, this carbon has a OH. Maybe this hydrogen and this hydrogen go away and it will be this one. Give me the other color, please.
By making water with another.
Not just lose the hydrogen. Lose of the hydrogen means
Hydrolation.
oxidation.
Oxidation.
This is the oxidation.
It's not hydrolation, that's water.
I know, I just...
The
Oxidation.
second one.
Primary alcohol oxidized to
Secondary.
aldehyde.
Yeah. And
Primary alcohol oxidized to
Aldehyde.
And secondary alcohol, where is the
Ketone.
blue color here?
Ketone.
Blue.
Blue.
Ooh, somebody learned the blue.
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 That's these two go and this ketone will be produced. Now, what is the name of this compound?
Are you asking me? That's a ketone, so it's propanon.
Propanon. What do you want to do? It's very dangerous.
Look at her, ready to say. Ready to
it's fine. It's written there.
No, this is the propanon. And these two OH comes to the propanon. On the carbon number 1 and 3. It means the IUPAC name of the hydroxy.
1,
this one
3,
is 1 and 3.
propandiol.
1 and 3 dihydroxy
Exactly.
propanon.
Sorry, I will.
Propanon, but it's written here acetone without numbering. Do you get it?
Acetone is propanol.
Acetone, it's a commercial name of propanon. But the IUPAC name 1 and 3 dihydroxy
And they will
propanon.
ask for it, yeah.
Yeah. In this teriols, teri means tricarbon, os means sugar. Keto, because we have a ketone. And here we have a aldoteriose. Ald because of the aldehyde. Teri because they have teri carbon. And ose because they are sugar. What's this star? Chiral carbon. But here in the dehydroxyacetone we don't have any chirality. But here on the glyceraldehyde we have a chirality. Why glyceraldehyde? They said this name is glycerol because all of them are alcohol. In this case it will be glycer with aldehyde group. If the OH is in the right hand, this is the D-glyceraldehyde. If this is the left hand, this is the L-glyceraldehyde. I think that yesterday we practiced that what does it mean relative configuration, relative stereoisomer in comparison with glyceraldehyde. We learn it to understand the isomerism on the
Optical.
on the peptide, on the protein. Just know this one. If we compare anything to them, this is a relative stereoisomer, stereochemistry
That is,
to determine the stereoisomer. D or L. D or L. No.
This is in the lab questions for next week, by the way.
Yeah.
Yeah,
Oh,
I did them already.
Yeah, me too.
No.
Do them
This is a chiral carbon here. I put the star. D and L. 1 chirality, 2 to the number 1. For this case, we have a 2 stereoisomer. Because it was the formula to the N was the number of the chiral carbon. It's written here aldopentose. Ald means
Aldehyde.
pent means
So
5 carbon. And because of the O's, all of the carbon should have a OH. Good? Now, in this case, how is understand this is a D-aldopentose? How? Why this is D? 2 and 3 are left. 4
This is
is
on
hard. The 1 is also not important.
Can you
You can turn it.
from beginning? Sorry, I
See, the question is why this is D? Why? Why this is D? This D.
because of the configuration.
How?
Because
if you
right,
see D,
A lot
and
of
then if
OH.
you turn it, OH
No,
will be
we
like
have
this
a lot of
group-
OH.
because this no.
You see, this is chiral, this is chiral, this carbon is also chiral. We have a trichiral carbon.
more go in this direction.
You see, more going to this
I
direction.
know you have to count and turn it around. and see.
No.
I just said
one
that.
thing. No, just one thing. Just carbon to the last. 1 carbon to the last is important.
Which one?
Number 5.
Who is the last?
Number 5.
5,
5. Who is the 1 to the last? 4.
4.
Just the carbon, no, carbon to the last, it means, I mean this one.
Okay.
Understand? It means 1 carbon to the last. How
Before the
is
last.
in English?
The one before
Just
the
carbon
last.
before to last. Such like that.
Because I left the TV. I didn't do that. That is so. You said left out.
آفرین نه آفرین means bravo.
Means what?
Bravo.
Oh,
آفرین
Afrin.
What is it in Germany?
Brav.
Brav?
What's the bro? Like bro?
No,
bro?
bravo, you know?
Oh, okay.
Oh, bravo. You can, but we say brav.
آفرین
You say bravo.
Maybe brav.
No.
Brav.
What is this one? Where is the OH of the carbon 1 to the last? On the
Six.
left
Yeah,
side. Carbon number 5.
5?
Just number 5 is important. Because of that, this is L. Because of that, this
I
is
don't
D.
get how does this become this?
No, this is
Oh,
not.
just showing. Okay.
Simplify.
You look at the one that is second last.
No, you look
Yeah.
at the chiral one.
The one before.
Second last.
The before the last.
I know second last.
Yeah, maybe second.
Second last, yes. Such
It is
like-
second
but
last.
before the last second.
Yeah.
That is second last.
No, we want to learn all the aldose family. That this family is summarized here.
This is the
Okay.
only important one?
Yes, and what should we know? It starts from the glyceraldehyde, means the grandfather is glyceraldehyde for the aldose family because
Is
it's
that
the aldehyde.
Fisher's test or
No,
something?
no, just forget this.
Okay.
He died.
Obviously, was that easy?
Just again, the aldose family start by,
Glyceraldehyde.
and the ketose family start by
Dehydroxyacetone.
That's a very important thing. Okay. No.
Okay, so the
Coming.
aldose.
See, they are not
I have a
colorful.
question.
Yes, question.
What is the aldose?
Aldose means the sugar with aldehyde. Sugar
Okay.
with aldehyde, good. Now, see this one, this is colorful, it's better.
Should I
Aldehyde,
fill
what?
like this?
Yes. Aldehyde is same. The black one is here. And the last one also. Just we add the third line, do you see? Okay, no. If the all of the OH is in the right hand, this is erythrose. No, Aisha, please. Just pay attention.
Okay, he's just gonna be here.
You know, he's so jealous.
I
He
know,
wants to
that's
come
why.
here, yes.
That's why. He's always coming to me. What am I gonna do?
Erythrose, oh my god.
Erythrose.
All of them are in the right hand. The D-erythrose. Why the carbon to the last OH is in the right hand. And L-erythrose because that's on the other hand. But pay attention that all of the OH are in the left hand. If they are opposite, it will be triose and triose. No. Again, if first of all of them are tetrose. What? Tetrose. How should we remember them? For sure you cannot remember the structure. I have one suggestion for you. If in the exam they ask, what is the erythrose? What is the tereose? Just remember this is aldose and there are tetrose. In this case, from 2 points you get 1.5. Because you dero just 4 carbon and you dero also aldehyde group. Okay, I forget the OH.
I have a question. Is it like cis and trans?
No,
Because
never.
yeah, but like if you think, because this is on the opposite side, right?
See,
This curve-
this is
triose.
left, this is right because
Yeah.
of that. This is left because of this. And this is erythrose because the OH are in the same side. This is tetrose because they are opposite side.
Yeah.
How should you remember? In the tetrose family, none of them has a L. Do you see L? L? No. But they are aldose family. The name of the family has one L. The other name doesn't have any L.
What?
In this sugar name, there is no any L.
But there is 2L.
Where? Do you see? No,
the
not
name.
this one. On
Oh,
the
okay,
name.
okay,
No
okay,
L.
okay.
In this case, they are aldose. They are aldose. The other type is tetrose. Okay? And you can draw it.
Tetrose means
Tetra-
4 carbon.
4. 4 carbon and ose means sugar. Now, comes here. Again, ribose and arabinose are pentose. Yes? They are what?
Pentose.
Pentose. You see on the ribose, all of them are in the right hand. Ribose, all of them. What's happened?
He didn't like her.
Jealous.
He wants to kill himself.
I know. He's like, "Ugh."
All of them are in the right hand because the name is ribose.
Nice.
Understand me? Now, how should I remember that
That's
it was...
arabinos.
I know. I heard it too.
Yeah, Arab inos. Arab inos.
Why
Okay.
is it called
What-
One
what-
OH is in the
Where
left.
does the name come from? I mean,
I don't
curious.
Maybe an Arab.
Yes, Arab knows.
Arab.
Precious are not the ones to talk.
From the Arab nose, it's coming again. That's sugar. That's the sugar from the Arab nose. Good. No, that's not important. That's very, very important.
Arabinos is not important?
And Lisa liked the important by the pink color. No,
This
What?
one is also important, isn't it?
no.
No?
This is important to know it. No,
I think
I
the
want to
arabinos
ask you,
is important.
how should I remember that the ribose is aldose or ketose? Again, do you see any L on the ribose
No.
name? No. But I want to show you the ribolose. See?
That's without an aldehyde.
Ribolose, it has a L.
Yeah.
In this case, this is ketose family. No L. You see, erythrolose has L. There is no aldose. It's the ketose.
Cellulose is a
You
ketose?
see? No. Just forget on the 6, after 6, the rule is changed, okay?
Why does he always do that?
See, the name of that is xylose, and the other one is xylulose.
More else.
More L.
What are you saying exactly? With an L?
If I have a aldose family, the name of the sugar until 5 carbon there is no L. If I speak about the ketose family, all of the sugar until the 5 carbon has L. Understand me? There is one L between the name of the family and subfamily. Now, allose is not important, alterose not. Like glucose and mannose is important.
Glucose is an aldehyde, aldose.
Oh, yes.
You see, it has L.
Yes, I told you until the 5 carbon.
Okay.
Until 5 carbon. From here, just know these two. How should I remember? The glucose is a aldose, hexose, okay? Carbon 3 is left. Carbon number 1, 2, 3 just is left. Good? Mannose has 2 carbon left. 2 and 3. How about the galactose? That doesn't draw it here. Where is the galactose? It's here. You see, this is also, it's coming, see, it's coming here, ribose, arabinose, xylose and lysose. The ribose make these two, it makes these two, xylose make these two, and lysose make these two. Lysose. Do you remember Lisa fever that I sent you? Lisa fever? We have a Lisa fever. That's a very dangerous disease. Why?
Really?
Yeah. It's on the Africa.
Of course.
Now, from these two, you see this is not a glucose, it's a glucose. Just the galactose is important.
What are they going to ask? Show the structure of galactose? Or
Yes, they said they wrote the galactose, mannose, glucose and write the relationship between them. I told you later what is the relationship also. On the galactose, carbon number 3 and 4 on the left. 3 and
4.
The other thing is not important. Again, ketose family start by dihydroxyacetone, yes?
okay.
Dihydroxy
What's the
and
IUPAC
acetone.
name for that one?
1 and 3 dihydroxypropanone.
Okay, oh, it's
1
the
and
same.
3, yes, that's the same compound. 1 and 3 dihydroxypropanone. Good.
But this is not important, yeah?
This is important. I make a
No, but
pinkish.
the IUPAC name.
IUPAC name is also important. Good.
Yeah.
Because today is Valentine Day, I make a pinkish lovely color. You see, it was erythrose. This is the erythrolose. There is a L here, but there was not on the L here. After the erythrolose, we have a xylose and ribolose. Ribolose is important to know.
Is erythrose and the other one important?
No. Just this one. You see, I tick. How should I remember? Ribolose has a R. R means all of OH are in the right hand. Good? And L indicate for you that this is a ketose family. Just there one ketose.
Ketose is what? Is that
There's a ketone.
Yeah.
And O's because that's a sugar.
Okay.
Good?
Okay.
Xylulose, forget it. Then ribolose make a piscose and fructose. Just know the fructose family. Now, on the fructose, you see, I told you again until the 5 numbering. That's you can use the L or without L. On the fructose, 6 carbon hexose. That's a ketose, and the carbon 3 is left, exactly like a glucose. Glucose is what? Aldose. Hexose, carbon 3 is left. This is not the aldose, this is just the ketose, just the different. Okay, but again, carbon number 3 is left. Tagatose and sorbose, forget it. Comes here. What does it mean? Epimer. Very, very important. Epimer. They are diastomer which have a different configuration around only one C atom. What's mean? That's a glucose. Glucose was hexose, aldose, and carbon 3 is left, yes? What is the galactose? Again hexose. That is also again aldose. You see aldehyde group? But carbon 3 and 4 is left. It means until here is same, just one carbon, just only one carbon is different between glucose and galactose. It means glucose and galactose are epimer at C4.
Okay.
What about the
different.
mannose? What about the
No, I tell you, no monos. Different epimer at C2. Why? Because just the C2 is different. Every other thing is same.
So, like, mannose and galactose are not epimers?
No.
I have a question. Can you draw it as a cycle?
Yes, I draw it also.
Because it said epi means over. Has it something to do with like
It was
the OH?
anomer. It was anomer. This is epimer. Okay. Now, what is the relationship between galactose and mannose? Compare them. Carbon number 2 is
Different.
Carbon number 3 is same. Carbon number 4 is also different.
So
It
no
means
epimer.
2 carbon is different, but epimer just only 1 carbon. It means there is no relationship between galactose and mannose. This is again mannose is hexose, is aldose. Carbon 2 and 3 is left.
Is it an aldose? Oh, yes, it is.
Yes,
Stupid question.
aldehyde group. Forget cyclic structure.
What is carbon, Sabina?
Okay. Like it? Good? You like this job? Okay, I make it for you.
Or she's gonna stand up and do blue.
Now, cyclic structure of monosaccharide. How can I cycle all of them? The story. I'm sure that you know how should you draw the glucose structure,
Yeah.
but what is the back historical? Always the aldehyde plus alcohol produce
It's
hemiacetal.
not good to put it like this.
Why?
Because the computer and they destroy each other.
Really?
Yeah.
Why?
Because of the magnetic and electrical stuff.
Wow.
It happens.
Really?
Yeah.
I always put everything.
No, it's not good. Especially if both are on.
Wow. Now, aldehyde and alcohol. What's happened there? You should remember from last semester that the aldehyde oxygen is partial
Negative.
Oh,
it's there.
Okay, he's there.
Yes. And carbon is partial.
Positive.
Carbon positive, the name is carbocation or
yeah.
carbonium.
Yeah.
Remember
Carbonium, yeah.
Now, what's happened? The ROH, H is positive, and all these part is
Negative.
see, this oxygen is pinkish. This is this oxygen. Even the other color. This hydrogen will be yellow. It's coming to this oxygen, plus to minus. Okay? And this part, OR, minus comes to the carbon.
Okay.
No. That's a hemiacetal. Do you remember acetal also?
No, I don't remember.
If I add one more alcohol, HOR second, not the prime second, what's happened?
Do what?
Second.
Second.
This, oh my god, sorry. This H by this OH
You know there are dogs here.
produce water, and this one comes here.
R, only R, no?
OR prime,
Yeah.
OR second, and H. This is the acetal, fully acetal. This is a hemiacetal. Hemiacetal has one OH. Acetal doesn't have OH.
Okay, that's it.
No. This one. That's it?
Ketone.
Ketone. Alcohol. What's happened? Again, carbonyl will be partial negative, partial positive. Hydrogen will be partial positive, partial negative. Proton comes to the oxygen.
Use the same color. Okay.
Yes. Oh, sorry. I was wrong, you know. Oh. Good. A little bit. Just this one is same. Hemiketal. What's happened if I add one more alcohol?
It becomes
HO.
ketal.
Or like this, it will be ketal. And what is the structure of ketal? One water go between this hydrogen and this OH.
So no oxygen.
C or R prime O or this, and it will be O or star.
Oh, just it.
What is the difference between ketal and acetal? Acetal has one hydrogen.
I have a
Ketal
question.
doesn't have hydrogen.
Where does the force R come from?
Where is the force?
Because here's only 1, 2, 3, and okay.
This is one. Force one.
Okay.
Now, on the exam, how should you distinguish? I want to write the note. Hemiacetal has hydrogen and OH. Hemiketal just have OH without hydrogen. Good? Now, consider. Why should we understand the acetal and ketal for? What is the name of this compound? How many carbon? 6.
6.
It has aldehyde or ketone? Aldehyde.
Aldehyde.
Carbon number 1. Which carbon is left?
The third.
3. Carbon?
3.
3.
So it's glucose.
Yes.
4.
Hexose, all those carbon 3 is left is glucose. That's the open chain form. What's happened? Who attacked whom? The carbonyl attack to the carbon 1 to the last. Always. Okay? It has an aldehyde group, it has an OH. Last semester we learned this one, 2 separate molecules, but it happens on one molecule from the head to the end. Not exactly end, 1 to the end.
Would it be the alpha carbon?
Just predict. This one, no, this is alpha carbon. Just predict if the aldehyde attack to the alcohol, who should produce? Hemiacetal or hemiketal?
Hemiacetal.
Hemiacetal, okay? And this is produced, and this carbon,
Can you explain why hemiacetal?
because it's
Because
an
it's an
aldehyde. If it was ketone, it was hemiketal, okay? Now, see this carbon, please. This carbon has one H, one OH, one R, one OR. See? This carbon has one H, one OH, one R, one OR. Again, one H, OH, R, OR. Understand? This is a hemiacetal. I just indicate hemiacetal carbon. This one also. Hemiacetal carbon.
Can you just write down C page before?
See page before. See page before.
Maybe you should take some pinkish
No.
color.
How should we remember? What should we remember? What coming on the exam? They ask for you, please, dero,
They never say please.
Only poto.
open chain,
And Tamas,
And-
or whatever his name is.
what?
Please, Loki, please.
Never say sorry.
Open chain and
Enzo.
cyclic form of glucose. Forget this structure. Just remember these two. Now, what is the difference? Why this name is alpha? Because the OH is down, and this is beta because the OH is above. What's happened for this OH? Carbon 3 is left, and I'm sure that you know the OH is in the cycle because this is a carbon number 3 and this is left. Left means in the cycle.
But you know, you said this epi thing, this epi.
Epimer.
Does it mean the OH is over? Does it have anything to do with that? No. No, okay.
Alpha and beta are different anomer. It's written here. Anomer. Alpha anomer, beta anomer.
What is anomer?
Anomer is a glycosidic OH and the hydroxymethyl group are trans. When this is alpha, they are trans. Why the beta is cis. See? In the alpha position, OH is down.
I have a question.
Yes.
I thought always when it's cis or trans, it has to be a double bond.
Yes. But we have a cis and trans on the cycloalkane also.
Okay.
On the cyclic. Do you remember? On the cyclic. This is like that. The OH is down. The other OH is above. They are opposite on the cycle. It's trans. But if they are same, it will be cis. What should you remember? Just remember alpha is down, beta is above. That's enough. Good?
But cis is like when this one and this one is up?
Yes.
Or just, where do you...
You see, we said beta means above.
Yeah.
No, and the beta is above, and with this OH is above, they are cis position.
Okay.
It's written hydroxymethyl. It's a hydroxy on the methyl.
Okay.
Okay. Furanose and pyranose. What is this furan? Tetrahydrofuran is saturated, and furanose is a sugar form of that with a lot of different OH. This is a pyran. Why is written here 2H pyran? Because this is 1, this is 2, and on the carbon number 2 it's saturated because it's saturated at
Carbon number 2.
carbon number 2. Tetrahydropyran, completely saturated, and with a lot of different OH group, it will be pyranose. Why that's important? Furanose is a backbone of fructose, 5-member ring, and pyranose is a backbone of glucose. You see, 6-member ring with 1 O. Understand? Just know that's.
And on both sides there are OH, yeah?
In this case, you see, just one of them is H, the other is CH2OH.
Yeah, but I mean just here in this, like, furanose has 2 OH on both sides.
No, it could be 2 OH or it could be CH2OH, CH2OH. For example, see, this is a fructose, this is a ribose OH, and this is a CH2OH. On the fructose CH2OH, CH2OH. It depends how many carbon should we have. What's this? Aldehyde. It's written aldehyde glucose. The type of the cycling is important to determine is it alpha or this is beta. For sure they are D. Why? Why they are D?
Because this first before the last carbon.
Yes,
is
because of this. OH was on the
second last.
right. Dextero. Why this is
Where's
alpha?
the OH?
What? It was OH before. Okay, it was OH before. Why this is alpha? You see the alpha position is which carbon number?
2.
1. Carbon 1,
Wait.
2, 3, 4, 5, 6.
Oh, I didn't see that.
Okay, carbon
Yeah,
number
one.
1. On the carbon number 1, you see the OH is in the
Right side
in the cycle.
in the cycle. How do you know?
You see?
In the cycle.
No, out of the cycle.
But how do you know, like with this, it's in
Yeah.
the cycle?
See, when we wrote that, I told you that the carbon number 3 OH should be inside. No, if this is carbon number 1, 2, 3, 3 is inside, it means this is outside. Inside the ring, this is outside the ring. Outside means above, no. Outside is here.
So is it always like that this part is outside, this part is inside? Can we think like that?
Yes.
This
Exactly.
outside, this inside?
Such like this.
Okay.
No. This one. Carbon number 1 is the same position with this one. When you draw the carbon number 3 is standing. It's again also standing the same. Inside. Inside. In this case it will be beta. No, not important. They never ask this one, okay? They never ask. Just understand.
I really like this picture.
You look like your
It's
mother.
really pretty.
Thank you.
Your nose looks like exactly like your mother.
But she's so beautiful, you know.
Yeah.
Yeah.
No, she's now 62.
No.
But
Really?
everybody think that my mother is about 40.
Yeah, she doesn't look like 62 at all.
No, see this one. That's a ribose. Ribose has a L.
What
No.
L? No.
It means this is aldose or ketose.
It's aldose.
Aldose, because the ribose doesn't have any L. Okay, could you please tell me where is the position of the OH of the ribose?
My boss was right, because it's
Right.
R.
Yes, because it's R. Do you get how should you remember everything?
Yeah.
Just by the coding.
Yeah.
Massa coding. Okay?
The math shipper.
The R, because all of them are right, and there is no L, this is aldose. No, okay, it's making such a cycle. Who care? Okay, I wanna draw it. Draw it. 5 carbon. This one, this carbonyl should attack to whom? To carbon 1 to the last. Yes?
To the last one? The fifth one?
To the 4.
Fourth one, okay.
One to the last. Okay?
First
Now, what's happened? It's look like this. 1, 2, 3, 4, 5. Now, all of the OH are in the right. It means all of them are down. Good? And this one also. Now, this and this. Okay, when it has carbon, it
have a
has
question.
OH. What?
This is the ribose one. This is not down. The OH.
No, it's written here. It's written here alphabetical. I don't know. They write it here. The drawing of the Fisher projection is different. It's like this, down,
Okay.
and maybe above, maybe down. Now, where is the OH of this carbon and this carbon? You see, this
Down.
carbon has carbon. This carbon has OH. Where is that? They combine together, and one water go away. If I add water, the chain will be, the cycle will be open.
Yeah.
Wait. Sorry, I know I'm being. But isn't this carbon number 1?
What?
This
Yeah,
carbon
it is.
number 1?
Yeah,
Yes.
yeah.
Then why did you say this one is up here? I don't know what you said.
I don't understand your question. Again?
No.
I
Yeah, it
explain
is.
again.
Because
Okay.
this is C, okay? O is this O, and H
I know
is up
that.
there.
That wasn't my question. You said this is up somewhere because
See, this is the aldehyde group. Aldehyde group is here, yes? It's attached to the alcohol of carbon to the last and the hemiacetal form. Hemiacetal has H and OH and one R and OR. Could you please show me who is the hemiacetal?
Can I see it back again?
See, this one should have one OH. If this is above, this is beta. If this is down, this is alpha. Because of that, I wanna draw it like this. It means I don't know, is it above or down? Different anomer. Different?
Yeah.
Anomer. No, it has one H also. H, OH, R, OR. It means this is hemiacetal carbon. Hemiacetal carbon. But see, for example, this carbon has a H, OH, R. There is no OR. How about this carbon? This carbon has a H, R, OR, and again R. There is no OH. None of them are hemiacetal. Just this carbon is hemiacetal. What should we remember? Just know this structure and this one. This and this.
Can you say why this one was hemiacetal?
Again, because it has a H, see, H, OH, R, OR is hemiacetal. This carbon has a H, we don't see it, OH, OR, R.
Okay. Whenever it's this structure, it's hemiacetal.
What?
Whenever we have this structure, it's hemiacetal.
That's a hemiacetal.
Okay.
No. What about the fructose? This is a fructose. Why? 1, 2, 3, 4, 5, 6 carbon. Ketone family. Carbon number 3 is left. That's a fructose. What's happened if the carbonyl attack to here or attack to here?
wait, this is an aldehyde.
That's a ketose.
Ketone.
Ketose.
Yeah.
That's a ketone. It will be a ketose. If the carbonyl attack to the one to the last, this one is produced. It means I would like to put it like here.
It's on that same page.
What?
Isn't it the same?
And the result will be this.
Isn't that the same?
Yes. Yes. Okay. And the other one, the result is this and the other. What I mean? Just see, if the carbon number 2 attack the carbon number 4, what's happened? This is carbon number 1, this is 2, 3, 4, 5, 6. Carbon number 2, 1, 2, 3,